in a car.
Then you go down through all of America. Then you go down through Mexico. You go down through those straits over the Panama Canal, and you go into South America proper, and you're in Ecuador. By the time you've covered either 6,210 miles, which sounds sensible, or 3,959, which bizarrely is the number we're given for the sphere. For some reason, we end up with a sphere number on the flat Earth, right? That's a big question. Why do we end up with 3,959 on a flat Earth is a big question in and of itself. Because we know the length of the equator, or we're wrong about length of the equator. Can we be wrong about length of the equator? Is this another argument from incompetence?
What is the length of the equator?
About 24,000 miles, because it's 24 hours around and going about 1,000 miles an hour, right? We've heard this from flat earthers. This is flat Earth evidence I'm using in front of you.
Well, actually, no, you're not using flat Earth.
Flat Earth evidence.
Excuse me, no.
That's a flat Earth claim.
Wow, fucking hell.
Let me just explain.
Is it not doing that? Is it not doing roughly 1,000 miles an hour?
Excuse me.
Tell him how they measure the equator. Go on, Jim. Go on.
Because we're not using the equator.
How do we measure the equator, Jim?
No one can prove.
Can you not? So it's an argument from incompetence. I'm not competent.
You're all arguing, but you won't let me finish. Right.
How do you measure the equator?
I'm just trying to talk here. Right, I'm saying to you that no flat earther will categorically say to you, yes, the equator is 24,901 miles. No one's confirmed that. No flat earthers confirmed that.
So you don't know how to measure it then, Jin, right?
The main argument is incompetence. I don't know how to measure it. Is their main argument. I mistrust your measurements.
Never been
not having a method myself. So let's guess. Let's guess. So we can guess enough. We can guess enough to say it's not 4 miles.
Ladies and gentlemen, we're not even guessing. I do not know the circumference of that equator. I don't know that. I haven't measured it. What I do know, though, that it's not an oblate spheroid. Drop of a distance isn't happening. We're not claiming we know the dimensions of the Earth or the shape of the Earth.
That's a straight line, Jin. It's a straight line, Jin.
Yeah, wrapped around a curve.
Straight linear line, ladies and gentlemen.
Yes,
is what we're talking about. Whenever we go in any
true.
direction, we're not measuring curvature.
So, do you think we can get Bev? I have a question for you, Bev. I agree, Jin.
No. I want to listen to Jin.
Its proper layout.
Jin, the equator is a straight line, isn't it, Jin?
I can use a plane and get to certain areas of this Earth, yes. But do I know the
equator is a straight line, isn't it, Jin?
No, I do not.
Jin, the equator is a straight line, isn't it, Jin?
I don't know what it is, ladies and gentlemen.
Oh. Does the sun not go east and west from ignorance in a straight line?
It's not an argument from ignorance, because we don't argue that.
At a certain time of year.
Yeah, it's a left to right circle from the north and a right to left circle from the south.
Know whether or not that circumference of 24,901 miles of a equator, because that's what it would have to be, is actually correct. We don't know that.
Jin, can we get a confirmation that you don't know how to measure the length of the equator?
It's not that I don't know how to do that, ladies and gentlemen. I haven't conducted that measwould to know that number is correct.
Right, well, how would you do it?
Although
I could recommend some methods.
Jin,
how would you measure it? Good question.
Indeed, a flat, non-rotating.
It's a great question, Bev. How would you do it?
The equator. No flat earther will tell you.
How would you do it? Were you to attempt to do it, Jin? How would you do it?
Well, again, there would be something for me to do for myself, and that would be maybe I fly.
Have you ever
maybe I'll use an aeroplane.
Fly?
Okay, that's a good one. Yeah, fly around the equator. You can do that. Like a few stops, but
an aeroplane isn't a measuring tool,
attempted to do, and then she
but you could tell. But here's the point:
the very, very last leg of a few miles away, nearly making it, and she disappears. Amelia Earhart.
So let's go 6,210.
You think you could measure a distance then, Jin? Like a horizontal
Basically,
distance?
ladies and gentlemen, if I was given the tools, I could probably, and I say that because, again, I have to use the tools.
So let me clarify for you.
I do feel if I could follow the proper track, maybe I can find out that measurements myself. But I need to do that. I haven't done.
So you could
let me clarify for you the difference.
Basically, ladies and gentlemen, what they're attempting to do here is squabbling. I'm not going to squabble them.
I'm not squabbling
because of the measurements that we have made already. It is not reliant on the equator. It definitely is not.
Yes. All right. It's a good thing it's not, because it wouldn't really work.
Give me 1 minute. Give me
we're trying to now prove is whether or not that equator is the actual size. That's a different argument.
Okay, give me 1 minute. right? At that certain time of year, you can put a stick in the ground, and where there's no shadow cast, the sun will be directly above your head, right? Can we agree on that?
Yes.
Right.
Yes.
Okay. Now you can mark that point on a map, right? You can then go for,
in a car,
like, say, an hour. This is a time-based thing.
Yep.
And measure another stick in the ground, right? And
great idea.
put that point on the map, right? That's two locations, Jin. Are you with us? You could measure that distance. It's a straight line, right, Jin?
Yep.
Horizontal.
Yeah.
For 1 hour.
But I already know that the Earth is flat. So what are we attempting to achieve?
Don't do that yet.
What are we attempting to achieve here at this point?
Can you do the maths to work out the total length of that line if you have that 1 hour straight line distance measurement?
Yeah. Okay. Well, what are we attempting to prove here?
24,901.
Well, you know, is it 24,000? So let me give you some stats. Let me give you some stats so you know what you're arguing about.
I'm going to measure every
distance for you, Jin.
mile of it. I'm not going to do this. Do 1 hour and then
measure.
That's not going to be accurate enough.
In reality,
what's going to be more accurate is to actually fly over the whole distance.
So let me give you an idea of what we're talking about here, Jim. We're saying, is the distance around going to be closer to 40,000 or closer to 25,000? And that's a big difference. It's not quite double, but it's getting there, right? It's huge.
39.
Yeah, 39,000 versus 24,000 thereabouts. 24, 25. So it's a big old difference, right? What we're saying is either
saved at sea. Think of all of the lives at stake.
Exactly. So if you're sailing and you go, we know how far we can make it before we run out of bread and limes and fresh water and stuff like that. And if we can't make landfall, we're done for. Then you need to know the distances east, west, and north, south. And what I'm saying is the flat Earth map, in order to keep the equator correct, has to keep the equator. If you can tell the distances, what Bev's saying is, if I stick a stick in the ground and can say that the stick going straight up and down that's plumb, you can also do a plumb. There's a telescope that will just hang on a weight and look straight up. And you just go, does the sun go straight overhead? And bang, a crosshair appears. For us, it goes overhead and bang, a crosshair appears on the sheet for an instant. You go, yes, I was directly under the sun. And if you can go, I was there and I was there. I was an hour apart, which are one of these lines, because there's going to be 24 of them in a map. Can I tell that straight line distance? And here, the equator must curve right. If you're going around with the sun, it's going rightwards. But if you're in the south, it appears to go leftwards. So you have this problem that if you're on the equator, it appears to go straight.
Feeding him. It's a straight line.
It's a straight line, but it goes in a circle. It's a straight line that goes in a circle. Well, hang on. Let's be clear. Let's be very precise, Bev.
I'm not about you, Jin.
Yeah,
north, south, east, and west are perpendicular, right, Jin?
Well, as we see it, I agree to that. Yes. North, south, east, west, they're all in opposite directions to one another.
Now, east and west, Jin, east and west aren't a tangent, are they?
East and west are not a tangent, no, because they're opposite, aren't they? They are opposite.
A circle.
Yeah, but it's not a tangent to...
It's opposite. The word tangent shouldn't even be mentioned.
Circle anywhere, right? There's no circles involved in it. They're just cardinal directions, aren't they?
Cardinal directions only at this point. Right.
Yeah.
Unless... So is the equator straight?
I don't know that.
Could it be both straight and a circle?
I don't know that. The word is I don't know. If I don't know, I cannot give you any answer.
Sorry. Let me ask you the question again. Can something straight also be a circle? You can have a straight line on a square.
Ladies and gentlemen,
I'm not going to. What about a straight line that returns back on it?
Silly
straight line that returns back.
It would not be a straight line. It would be a curved line.
Why not?
Because if you're going to come back on yourself, you're not traveling in a straight direction. No, you're taking a curved trajectory.
Doesn't the sun go?
You're taking a curved trajectory. You're not taking a straight B line. You're not doing that. You're taking a curved trajectory, holding a heading.
Is that not what east and west is, right? Straight line.
Or is it a circle?
You see, if I'm using a compass, and my compass is now relying on, I'm going to move in an easterly direction, that would be anti-clockwise, okay, right? Easterly, anti-clockwise. Now, I'm going to end up going in a circle because of the magnetic needle that's pointing to north. So, but if I hold a heading and ignore what the compass is telling, but I hold a heading of a straight line and fix my rudder on my aeroplane and everything, so there's no deviation. I'm just going to be heading in a straight line like that. That's a straight line to me.
Fix the point at north. You don't think you can do that with the magnetic field lines, can you?
No, they're all wibbly. Magnets are a terrible way to find north. You find north in reality, and then you see how far the magnetic north is off, so that people can sail using magnetic compasses. But magnetic compasses are dog shit for finding north.
What we might, well, I don't know. People don't get lost with them anyway, and they use them all over the place. I use them as well in the military. I never got lost. Ladies and gentlemen, it's this. What I would say is this.
You're giving your local destination.
I'm trying to speak now. Right. You're squabbling here because flat is flat. Linear distances are linear distances. That's what we're measuring. I don't know what you're doing here. It's not going to bring your globe. You're still interrupting when I'm trying to talk. I've told you before, when I'm talking, don't interrupt. It becomes messy.
About linear distances.
You're still fucking interrupting. Basically, ladies and gentlemen, I will carry on because these idiots that don't seem to understand the King's English. It's this, ladies and gentlemen, when you are flying around the world and you don't experience curvature, when you sail and you don't sit, you don't experience it, where are you? On a flat Earth. Why? Because Earth is indeed measured and utilized flat. That is the actuality. That's it. Thank you.
Yeah. What's your throat? You do realize you just said you're flying around, didn't you?
So now we're going to start playing semantic with words.
All right.
We can travel around my neighborhood, ladies and gentlemen.
But we were just talking about straight measurements.
Silly here. If I want to go from one place to one place to the one place to the one place, I'm moving around the world. If I want to go from one place to the next place in my neighborhood, I'm moving around my neighborhood. Right? Let's not get silly here.
Yeah, well, we were talking earlier about measurements, right? They are all
curvature, ladies and gentlemen. Curvature and flatness.
If you're talking,
the Earth is flat, measured flat, utilized flat.
Yeah,
we're not just about
to say they are horizontal distance,
and we would know it because our senses are there to recognize and feel it. We're not feeling it. Simple as that. Thank you.
Right, these measurements that we're talking about are horizontal distance measurements, Jin, and they are straight line distance measurements.
Mm-hmm. Welcome to flat Earth, then. Thank you.
Well, you're the one, Jin. You're the one that makes a circle, and that circle has.
I don't make any circle. I don't make any circle. Sorry, stop lying.
Well.
So the easy way to do it is in kilometers, because that's how kilometers was kind of set. That's how
miles is. I prefer mileage, so I'll use miles.
Yeah, but miles are shit. Miles are dumb.
6,200.
No, miles are not dumb.
24,000, Jin.
Let me just use kilometers because the numbers don't mean anything to anybody anyway, right? 40,000 kilometers. Right, but let 40,000 kilometers in circumference, right? The equator.
24,000
on a sphere, that should exactly right. Yeah, nailed it. That's a ratio of 2. So you've got this issue.
I've noticed you've dropped 100 miles because it's meant to be 24,901. That's what it's meant to be, isn't it? And we haven't confirmed that.
What are you talking about? I've just got 40,000 kilometers. I'm switching to kilometers because I asked AI to do it for me. So the question of is the equator 40,000?
It can't be.
Or is it 20,000, right? Exactly. Which is it? So you need to go, because now every other time you try to test the flat Earth, you're looking for these tiny numbers, this tiny amount of refraction.
Ladies and gentlemen. It's not reliant on the equator. Flat Earth is not reliant on the equator. Stop that. Okay, it's not. It's just relying over a curvature over a given distance, wherever you are on your imaginary Earth ball.
Can you answer to it?
It's got nothing to do with the equator. So
you can't answer to it though. We know the distance of the equator.
We don't need an answer to a fake number that was given to us. We can disregard that completely.
You don't have any other numbers. You can't give us a number for the equator.
Look, we know the Earth is flat. That's what we need. We need to be. Do you know what we need to be?
No idea on the number of the equator.
They're giving us poisons.
They're lying about light does.
That's funny.
They're
creating wars. They're lying about the very thing we live on. We're not wasting my time over the equator. The equator is not a requisite to knowing whether or not I'm on a flat Earth. Don't be silly.
You're just avoiding the argument. This is just verbal graffiti.
No. You're being silly. You're putting upon the flat earthers things that we do not need to consider at this point. After 10 years, you've had a bachelorette for 10 years, remember? And this year is going to be particularly the year of the horizontal constant. I'm constantly going to be reminding you of the horizontality of this earth. That's what you're going to get in your head.
Does pi equal 2?
Stop the arguments about going towards the equator and shit like that. That's not
becoming incoherent.
It's a circular square.
It's not flat Earth arguments. It's not.
Flat Earth Rambo on the fucking.
That's you people
circular square,
walking around the village,
prop up and revive the globe. Round. The globe is dead in the flat Earth water. I'll shut up now.
We hear you, Jen.
Does pi equal 2 is the question.
It has to.
Right. Pi must equal 2.
Yeah.
Because the same distance around, like a square. Because if you go round 4 times on a square, you get back, and to the middle is the same distance. So we know that pi equals 2 on a square, because pi doesn't exist, right? It's just the distance to the center is the distance to all the way across, and that's 2, obviously, because it's a square.
It's not a square.
That gives you the same if you wrap it around.
It's just not Euclidean. Come on.
Yeah, it's not Euclidean. What? Because the equator has to go in a circle.
Pi equals 3.142. That's Euclidean pi, right? And what this shows is that it's not Euclidean. And Jin's okay with that because, Jin does the maths. They've worked it out. They know that the globe comes from flat Earth measurements, and they know that the flat Earth measurements are pi equaling 2. That's how you make a globe. For fuck's sake.
Yeah, exactly. You need the flat Earth to have your globe. But ladies and gentlemen, I have forgotten my manners. 2026, Happy New Year to all of you, and may you all continue to have good health and continued prosperity throughout 2026. And please bear in mind that 2026 will be the year of the horizontal constant. You're going to hear that constantly from me because that's where we live. And Earth is indeed measured and utilized flat. Okay? And be careful of the globers bringing in arguments that flat earthers do not bring forward. Nothing to do with us. They're trying to dump some crap on us, but we've got our hazmat suits on. That's not going to happen here. Thank you.
I appreciate it, Jim. Well, what did I miss?
Thank you, Jim.
My phone died.
I think Jen overpowered your battery.
Actually, I just listened to a cool conversation with an astronaut. So is it? No, he did nuclear physics, and a guy from Home and Away, and he did Neighbours in Australia. Like he was an actor or something.
Very cool.
Great. Dude, Eggshells, I'd love to share. I'll send that link to you. They talk about the world in a different way, and the nuclear physicist has essentially he goes flat Earth within 15 minutes in the conversation, but I think he just unpacks the materialism versus the sort of, I don't know, for lack of a better word, spiritual aspect of the world. And I think you're that way inclined a little bit at least. So it's just kind of cool to listen to a fella. I don't know. That's why I reckon it'd be you'd appreciate it anyway. I don't go.
Are you asking that he could stream it for us? Is it a short video?
No, it's an hour and a half. And there's no clips to be taken of it. But when I jumped on the server, I was listening to that in the background. And then Bev started telling me that I was in Banjo's videos. I was like, "Oh, this is saucy. Let's go check this out."
Yeah, I found out I'm in QOps videos too. I guess I don't know if it's a new one or an old one, but I haven't watched any of it because I know his arguments suck. So
yeah. Well, I mean, whatever. But I don't know. I just reckon we'll stream it sometime, or if you want to.
Could you share it to me so I could put it in the rotation, Rick?
Yeah, for sure.
Appreciate it.
I can't look at my phone right now. I've actually got it in the fridge.
Yeah, no
I'm
worries.
talking to you guys through
Whenever
my Bluetooth device, but I've just got to cool down my device. It's overheating and it can't take charge because it's too hot.
No, I should get some ideas for you. I just drove the Unimog with like all of the wiring just stuffed into the glove box. It was ridiculous. It was such a fire hazard.
Yeah, right. Okay. Oh, that's interesting. I just released a camper van for rental. I just released a camper van for rental, dude, and I was like, oh, and he's wired up electrics on boats, like as part of his profession, and he was looking at my stuff, going, oh, it looks a bit dodgy. I'm like, I've tested it all, and then he asked me to correct a couple of things. I just fixed him and sent him on his way. Dude, today's been hectic. I had to fix that whole. It's just, I'm not going to go into it, but yeah, crazy day.
No.
Did I see QE?
Where do we get with Modus Tollens?
Is he up for debate?
So Modus Tollens is if Euclidean maths is true, then the Earth cannot be flat because we know the distances overland well enough to tell a difference this big. It's a massive difference. We're looking for east to west distances changing where Australia goes. Listen to this, Riksky, because you've driven across, right? You drove across from Perth, right?
Yeah, I was going to mention I went 5,000 kilometers in that trip, bro.
So is there any chance that you did 9,000 kilometers? Is there any chance at all possibly that you did 9,000 kilometers?
Not according to my odometer, no.
Okay.
How could you guys do
how long could your odometer be for you to have done overnight? Because 9,000 by my calculation is a straight linear plane flight. So you would have done 13,000 once you've done all your parking and motorways.
Baked into your assumption is how the sky works, imposing it upon the ground.
No. Just your odometer, just your odometer and maths. Just your odometer and maths. I'm saying, is there any mathematical way your odometer could have possibly misread that it should have been about 10,000 kilometers?
I mean, it would have misread like a small amount, but I could imagine only about 100 or 200 kilometers.
No, we're talking more than double. More than double.
Yeah. No way. Not possible.
Okay. So we now have disproven the idea that the equator is wider than it is. So Flat Earth already had the problem that if we just wipe that possibility out, now we've got 4,000 kilometers, which is what we're told it is, versus 6,000, which is if you preserve the equator. But what you've wiped out, what you've agreed with me now is you cannot. No. What we're doing is if we know that.
That's all you've proven. Continental distance, not flat Earth.
Yeah, continental distance overland. So if we know that people overland travel from the equator to the North Pole and it's not 6,000 kilometers, what you've said is, it can't be 6,000 kilometers, 6,000 miles. I forget what it is, 20,000 kilometers to the North Pole from the equator. Cannot be, right? We have ruled that out. So what we must preserve is the equator at least. And now you should be reading
a map of Australia on the Gleason's map. I mean, if your math is correct, is wrong. Yeah.
We must be smaller than the equator. We have to be smaller than the equator because we know the distance and the length of the equator and how fast the sun is moving.
Why
we
don't
know
we
that
just
it's
do
doing
it like we do it in the north?
But there's no way that you drove 9,000 kilometers to Sydney, right? Otherwise, your odometer is fucked and reads double the distance different once you turn up the coast and you came up to meet me and we had awesome beers. Fuck, I got to meet Riksky. So good on you, man. It's so cool you did that road trip too.
To the show.
So it's just not possible. Maths tells us pi cannot equal 2. So we cannot preserve the overland distance.
Euclidean.
Exactly.
Euclidean maths
we
tells
must
you
use non-Euclidean.
pi can't equal 2, but non-Euclidean, pi can be whatever you want, can't it?
And exactly.
What would that confirm? That the when the sun rises and when it sets upon the continental of Australia, that the distance, how would you call it? The distance must be accurate as far as the course of the sun overtop it. So, how far the sun travels above continental Australia. See,
you can ignore the sun. It's just overland distances.
The sky.
How accurately can you locate your latitude?
No, but when the sun rises and when it sets, according to your interpretation of the sky, is pretty much accurate. Well, relatively. I mean, did I?
I spent actually got it
5,000 kilometers, but I went up and down and I traveled all around. Like it's not a direct line
maps
at all.
Aren't wrong. Exactly. And you never found a spot because you've now done a lot of traveling. You've never found a map that's wrong, that's suddenly got 5 kilometers too much in it to fit somewhere.
How accurately can you guys locate your latitude?
How can we locate our latitude?
Yeah. How accurately can you locate your latitude? Yes.
I think I could get it to within a degree.
Like pretty precise. I don't know, within a meter. Like, what do you want?
Right.
Meter.
Well, do is you measure the distance. You locate that, and then locate a 1 degree change going on a north-south line, right? And then you measure that distance on a map.
Yeah.
Sure.
And if it's Euclidean, then it is both a circle and a straight line. If it's
non-Euclidean,
then it's fine that it's a circle and a straight line. But what
you can extrapolate one out to 90, can't you?
Well, to 360 generally is a full circle.
No. Just for 90, because you're talking about latitude. You're going from the equator to the pole, and there's a 0 to 90. So that's all you're doing.
It goes all the way around 360, doesn't it? It goes 0 to 90. Does it stop at 90 or does it continue after 90?
Well, they're all perpendicular, right?
Where does it continue up till? When's the final number before it starts again?
But mathematically, once you get to 90, you then start it again, don't you? That's mathematically.
You go to 110 and 20 and 180, and now you're at half a circle. Then you go to 270. And then you go to 360, and then you're done, and you start again. What?
No, if you get
this has been since Babylonians.
If you get to 90 and then go past it, it's just like where you came from. It's just
it's 91 degrees. There's a number for it. There's not a number for 361 degrees. There's not even a number for 360 degrees. But there's a number for 91 degrees.
What? So you think there's a 91 degree north, do you?
What? Sure. Yeah, if you're in the south, it's not more than 90 degrees away.
No,
of course. That's how the south works. It's 180 degrees from the north.
0 to 90.
Yeah.
And then you've got
it goes to 360, bro.
90 on the south.
Circles go to what? Circles go to what?
What?
Somebody tell me when a snowboarder completes a full revolution, please.
No, we're talking about angles.
Thank you.
Measured on the ground.
Yeah, and it goes to 360, bro. It doesn't stop at 90 and restart.
Is this a trivia? Like, can we play? Okay, I got 1 point. Okay, you guys, you got to catch up. Okay, let's go. Continue. It's freelance trivia. At the moment.
I'll just point out that there is no 91 degree north latitude.
Yes, there is.
Doesn't happen.
What do you mean 91 degree north? Oh, I see. You mean on a map. So on a map, I kind of agree. It goes to 180, I would say, but it's positive. I see what you're saying. Sorry, I completely got it wrong. I see what you're saying now. I'm so sorry, Bev. You're saying on the on the longitude line.
I lose a point now.
On the longitude lines,
these maps,
we go positive 90 to negative 90. So it's 180 degrees total range.
Yeah.
Because of
longitude
line goes around. I'm sorry, Bev.
Right? Because each one of these from 0 to 1, right, where that change in degree happens, we can measure that distance, and that has a distance. We can plug that in, and then we can do 1 to 2, 2 to 3, and just keep adding all of these up until we get to 90, and then that's how we know 6,210, because it's 90, right? 90 of these 1 degree divisions, right? So exactly. I was asking you guys in the south, how accurate can you be? Because you can extrapolate from 1 degree to 90, can't you? You can have another distance and say, there you go, that's another distance.
And in America and Australia, the British just tended to draw borders north, south, and east, west. So they drew them along longitude and latitude lines. And states ever since have argued and gained and lost territory by resurveying it and getting it more accurate to the lines, right? To the state's lines. So that tells us we must know where longitude and latitude are. And we can tell if Australia is fanning out or shrinking down to a point. And Australia is shrinking down to a point. As you go further south, and east-west distance is shorter. It's longest at the equator, and it's 0 at the pole, where Whitsitt went, right?
What? East-west distance?
East-west distance is shortest at the pole at 0. At the equator, it's 40,000 kilometers around.
What do you mean, shortest? Like a mile?
If you go east, if you stood on the south,
there, right?
No, I mean, if you wanted to complete a full revolution around following north and you were at the equator, you would go in a straight line around the equator and do a 40,000 kilometer journey. But if you're at the pole and you wanted to travel, sorry, I keep saying the wrong cardinal direction. It's my fault again. Sorry. If you wanted to go west, if you're standing at the North Pole and you wanted to go west, you just walk in a tight little circle, right? You do it in a couple of steps.
Is that playing to gin, that? Are you just allowing gin his east-west circles?
Do you think east-west is a circle, or it's a cycle that repeats in a straight line?
It's a cardinal direction, right?
Mm-hmm. But the sun, do you think it travels in a straight line on the equinox?
The sun,
Is it a straight line?
Yeah, it's a straight line.
Do you think the equator is a circle or a cycle? It goes around?
A straight line circle. It's a straight line that turns back on itself, right? If you count
it's a straight line that turns back. Hang on, I've got to write that down. It's a straight line that turns back on itself.
Yep.
That's so good.
A straight line that turns back on itself. What are you describing? Like, it's a straight line around a sphere. Okay, this it brings up my idea that I was thinking before, right?
Mathematically, it's called
you can either flatten the sky or you can flatten the Earth within both of these prospects, from what I can tell.
Just ignore the sky.
And you guys are choosing to flatten. But that's where you get all your GPs and all your distances from.
You don't need them for this. You just need pi and distances over land that you can walk. So you can ignore that and just go. Do I think pi is true? And absolutely, pi is not true, right? We fucking know if squares were circles. So,
squares can't be circles.
I don't like this idea, man.
It's a straight line that turns back on itself.
Yeah, but they're both Euclidean. Squares and circles are Euclidean.
Yeah.
And we know it's not Euclidean, right?
Mm.
That's where you might get a little bit confused here.
Is the moon rising for you? Was it eggshells?
Possibly. I'm not outside. I could go look. But it always do show in the east, right? So the question is, how is the equator a straight line that turns back on itself, that goes appears to go in a cycle that is a straight line that turns back on itself? I'd call that a circle. You're in the center of it.
Depends on the geometry.
Because you're still thinking Euclidean, right?
You're telling me to ignore the sky, and then you ask why the sun travels a straight course across the sky, and then you're saying, well, just ignore the sky, only worry about the land. It's like it's kind of really a bit of
ground.
It's an odd interpretation.
There were points on the ground.
So I'll be back.
Okay.
Yeah, we were like measuring the distance on the ground in between 2 points, and everyone knows that's a straight line.
Hello.
Two distance on a. Well, it's not straight though; it's curved, right? Eggshells. You have a hot micing.
Good. To be on the grass, spill all the tea. Who's on?
I'm gonna get him.
What is he doing?
Someone else get him? No, not yet.
These are globers having a conversation about how they know Earth's a globe.
It's globe, yeah.
Move to the hot mic. There we go. Well, I mean, so when you say tis globe, right? You at that point must assume that the sky is flat, because you're saying the ground's curving.
No, I don't. I'm not saying curving. You didn't hear me say that. You heard me say.
When you say globe, what do you mean by it is globe?
Not Euclidean.
The sky. So when you say tis globe, it means not Euclidean.
It means the mathematics that we've just explained is definitely not Euclidean.
Do you know what?
Right? And there's no way you can comprehend the way this is, because your brain will only comprehend Euclidean. Because
Rick knows what ball is.
is contradictory. A ball is Euclidean.
Your brain will not perceive non-Euclidean. I mean, are you talking about what the eyes perceive in the interpretation that the brain would sort of receive that as a message?
Your brain's only set up to deal with Euclidean reasoning.
Wait up. Is that like an evolutionary argument? Is that an evolutionary argument to say that like you're born on this terrestrial plane and that you're set up for the plane interpretation, like because you're so close to the ground, so you couldn't perceive the globe?
Definitely not a plane. A plane's 2D, and it's we live in.
Well, they call it the plane of existence. Okay, so like you're saying that you seem to be indicating anyway that you perceive the world as a flat surface, yet you would deny that interpretation.
Absolutely not.
Okay, well, correct me where I'm wrong.
Well, it's not flat, right?
What's
absolutely
not flat?
Certain it's not flat.
What is not flat?
For one. Mountains for one. They're not
okay,
flat.
radio. So yeah, cool. Radio. So it's not flat. Okay, topological plane is the other.
That's an oxymoron.
Instantiation.
That's an oxymoron.
Well, it's
a plane's 2D and the topography is 3D representation.
Okay, but when I talk about
2D
when I talk about the level of like the sea, right? And we go to you got the Dead Sea, you got all sorts of different oceans. When I draw a line across those, yeah, I can see that the Dead Sea is like, if I draw a horizontal parallel level line, I can see that the Dead Sea is below the sea level.
Yeah. On the vertical datum.
Okay. Yeah, for sure. Vertical datum, no worries.
Yeah.
But you don't like, what is it? You think that the vertical datum instantiate, or is it a center point that it emerges from?
No,
you're interpreting that from the sky.
You're thinking Euclidean again, aren't you?
So yeah, what is that? Do you want to go back to that? What do you say that I'm thinking Euclidean?
You should listen to me, Rick, because I can help.
Yeah. Oh, well, if you want to unpack it, I don't mind.
Don can help you.
He's saying, Earth is not just Euclidean. I mean, it's not 2D like the flat earthers say. Doesn't care about
part of the Earth?
And hang on. He's saying it's got to be non-Euclidean, and which means curved. Yeah. So I don't know what type of curved Earths there are, but there's one or two or three. I've nearly finished. And then he's teasing you, saying you can't conceptualize Earth in a curved way. So concave or globe or some other hill Earth that Bev might believe in.
Yeah, but the wider interpretation would be that if you're perceiving that from the sky and you don't know whether if you say that the sky is flat, then you instantiate that the ground must be curving. I can understand that reasoning.
No, that doesn't make sense.
If you make an observation about the ground being flat, then you can then possibly, if you could prove that, absolutely prove that the Earth was flat, then it must necessarily be that the sky is curving.
Why? To make all the measurements work?
Yeah, because I mean, as far as I'm led to be aware,
that's a different argument.
The universe is perceived as flat. Like the upper heavens are considered flat. That's what allows the curve of the Earth to sort of basically
all Bev cares about is debunking your ground geometry.
Yeah, but if he's making assertions,
that
the ground geometry must be. Because
you know that isn't what I'm thinking or caring about.
No, but dude, basically astronomers suggest that the universe is flat. That's what they tell you. When you look up into the sky and you see all those stars, there's very little parallax going on.
Just means three-dimensional, Rick, when they say the universe is flat.
Okay, now we've got Euclid. No, it means 3D when they say it's flat.
I googled it the other day.
That's hilarious. No, from a relative point of view, the Earth, if you are on a sphere,
with the
right?
Information.
If you are on a sphere and the what you observe in the sky is rotating around you, I can understand. The sphere is Euclidean now. Is the sky flat or not?
Absolutely. Book 11. Solid.
There you go.
I can tell you in my reality, in Bez's reality, and in yours.
The sky, relatively speaking, from your perspective point of view, on a globe must be flat. That's the only thing that resolves all the points. But then the problem is, what is that? If you
do you mean
if you make the instantiation that
when you say
what's your
do you mean a sphere like Earth?
No, it's the relationship between the sky and the Earth at that point. You can either assume, like, you can assume that one's flat. One of them has to be.
No, just think
because of
about
the way
this
that
and
the
your
GPs
words.
work.
Rick, be careful with your words, right? If you've got a sphere, how can the outside of the sphere be flat? The outside has to be curved to go round.
It does sound like you've set up a false dichotomy there.
Relatively speaking. I went through this like in earlier.
Yeah, but that isn't what flat means. You mean it's a sphere, like the sphere.
Relatively speaking, through sort of like Einstein's like sort of interpretation of space-time, the sky must be flat then.
Well, that's how you know it's a globe then. If you believe the sky is relative to Earth, that's how you know it's a globe, not flat.
No, that's not. That's
yes.
I don't know where you're going wrong in the argumentation there, but one of the two is either flat or curved, right?
You're in semantics worse than Bev today.
You've set yourself up a false dichotomy.
Somehow.
Okay, Bev, who are you accusing that statement of? Like, is it me or Dawn?
You.
Okay,
so you're saying it must either be this or this.
Yeah, essentially because the GPs of the stars and the nature of the way that we predict distances, you've got to like. I think that like when you come to relativity of interpretation, like when you do the math out, essentially what means that if you think you're living on a globe, you have to flatten the sky. The sky has to be flat because of the relative sort of measurements that are occurring between the two planes of existence.
Yeah, well, I'm saying it's a false dichotomy because it's neither flat nor spherical.
No, but the sky is observed as flat. This is what we got from that documentary called The Principle. Astrologically speaking, they interpret the sky as flat because of.
Thank you very much, Riksky. Absolutely, I'm going to post it now. Yeah, bang on. The Principle. That was their conclusion, that the sky and space is flat and Earth.
No, you said it as well.
Yeah,
they mean 3D, Jen. They mean the space is 3D, not 4D.
No, it's perceived. No, don't worry about what it actually is.
Of course, I'm going to worry about what they mean, and I'm going to teach you the truth about it. Of course,
in the Euclidean geometry of the perception of the human being on the object that we call Earth, looking up into the sky is flat because it's such vast.
You completely misunderstood what everyone said about it.
I think I nailed it. I may be deluding myself, but
yes, you're preaching flat Earth religion. It doesn't even make sense to what I was trying to tell you.
You're the one preaching, bro.
What am I preaching for? You understanding Bev. That was why I got heated, because I want you to understand what the other flat earther Glober is saying to you.
He wants you to understand me. That's most imperative to Dawn, right, Dawn?
Yeah. Don't you want the same thing, Bev?
Well, couldn't I talk to him?
No, because half the time your ego makes you take him in circles. So I want to get in so that he actually knows what you've said.
But you don't know what I've said.
I do. I listen very carefully. I've known you for years. I've known Rick for quite a few years too.
Yeah, and you've most often misrepresented what I'm saying, like most people do.
No, there you are.
They want to seem to speak
have a second point of view on it because you talk in circles.
Well, that's only because other people try and interpret what I'm saying. But you're going to go to Euclidean.
You said Earth's a globe. Right? That's the real interpretation of what you said.
The globe is non-Euclidean.
Earth is non-Euclidean, curved. No, so which curve do you mean?
The globe is non-Euclidean.
Yeah, you said reality is non-Euclidean.
No, the globe is non-Euclidean.
What about reality?
Reality is the stuff around you, the local stuff.
Earth.
That's totally Euclidean.
Earth's totally Euclidean now. You've gone back.
No, local is Euclidean.
See what I mean by the circle?
Global.
And now he said
global.
Earth's globe. Now he said Earth's flat.
Global is non-Euclidean.
And that's what I tried to warn you of.
Opposites. Local and global. They are opposites. They are as opposite as up and down.
Sometimes you teach the truth, but a lot of the time you contradict yourself.
Up and down is part of the whole. So is local and global. They are opposites.
Nice script, bro.
I was going to say that Dawn made a statement earlier on. This is how globers discuss, and this is how they know that they're on a globe. But they've offered no proof, and they don't know they're on a globe. Ladies and gentlemen, for to know you're on a globe is to have actually measured it and confirmed it. That has not been done by any human being. By any human being.
But you get pissed off, isn't it?
I don't interrupt.
Because I have actually measured it.
You haven't measured any curvature.
What I know.
Yeah, I've measured Euclidean nature.
You haven't measured curvature of the Earth.
That's why the globe has got
has measured curvature of the Earth, ladies and gentlemen.
And
he's talking locally flat.
It's local non-Euclidean now.
If it's flat locally, that means it's flat across the world. Because from when you move to the extremities of where it's local and you start again, you're going to measure another piece locally flat. So can you see that they're slowly edging towards flat Earth as it is? The idea that Earth is we're measuring locally flatness is an absurdity beyond belief, because it is just flat everywhere. Silly.
Jin, let me speak to you.
Yeah, go ahead.
It's totally fine for you to think Earth's flat, but you don't get to tell me what I know. I decide what I know.
No human being knows the Earth is a globe, ladies and gentlemen. To do so is to measure.
You can say it, but you'll never have control over my actual knowing.
It's never been proven. No human being has done that. No human being has gone out and measured curvature to the Earth. No human being. Why? Because the Earth itself is as a globe does not exist. The Earth as a globe doesn't exist. How do we prove that? Through the measurements of the Earth being measured flat and utilized flat. And the people who are listening in the YouTube, they know that. No, I'm sorry. You're not
best case scenario, Jin.
You're not proving curvature.
They're not equaling 2.
They are not proving to you curvature, ladies and gentlemen. This is the crux of the model they have. It is not curving anywhere on our real flat Earth. Thank you.
Yes.
Horizontal constant everywhere.
Isn't a curve because it's just non-Euclidean.
Here we go again, ladies and gentlemen. So now you're not living on a curve, right? See how stupid it is? That's what I mean. Listen to all this gobbledygook and nonsense.
Jin, I'll talk to you properly.
Living on a curve.
I like to.
You're not living on a curve now.
So you don't have to preach to me. I'll talk to you properly.
I'm talking to you properly as well, and that is definitely no human being has measured the curvature of the Earth. The Earth as an oblate sphere does not exist. I've been doing it for 10 years, man. We know already. We know there's nothing to discuss. It's just reaffirming
it. So you're just
saying
it.
We are reaffirming. Okay. The word is reaffirming.
Okay. Tell me when you're finished just saying things, and then we could talk.
We are reaffirming to you the facts and the reality.
Yeah, tell me when you're finished.
Go ahead, Dawn. Sorry.
Yeah, do you get my point? Reaffirming doesn't do anything. We already know each other's position.
Right, lady, have you finished, Dawn? Because I want to make sure you finish before I speak.
Ladies and gentlemen, Dawn.
I'm saying, let me know when you want to discuss things instead
of
ladies
and gentlemen, reaffirming the fact that we've had a 10-year win against the Globers. They've lost for 10 years due to the fact that they can't prove their globe. That's what we're reaffirming here. No human being has measured the curvature of this Earth. Why? Because the Earth as an oblate spheroid does not exist. How do we know this? We, the flat earthers, have gone out to try and measure the curvature, and we are met with horizontal constant. The horizontal constant constantly everywhere. That's what we have. That's what we've been met with. That's what met us, or we met, or greeted us. The horizontality of everything. No measurable curvature, no drop over a distance can be seen, measured, or felt, experienced. And ladies and gentlemen, have you done that? Show me. Thank you. Yeah. For we are the champions, my friends.
I wish you all the luck, Jin.
I don't need it. I don't run on luck, ladies. I just run on the truth, mate. The truth is we're flat. That's it.
Not got a clue what's coming, but I mean, that's all right. Don't worry.
There's nothing
coming, about. What's coming down the pipe?
Yeah, what's coming down the pipe?
2.
Pi equals 2.
Yeah.
You don't care about the math, bro. They know it's all a mess.
Why would you say pi equals 2?
That was
because the measurements, the best case scenario for your measurements, you're going to end up with pi equaling 2.
No, flat earthers don't trust worldwide measurements in that way. They think it's all distorted.
It's not necessary.
Well, that's why you can do it yourself. You can actually do one of these measurements to make sure that between an angle of 1 degree change to Polaris, only available to the Polaris privileged people, this particular one, and then measure it on a map. Like, I take it you trust your local maps with the distances and the scales.
Not always. They don't know. Jin doesn't, does it?
I don't know. Where's Jin live? Japan? I would imagine they're pretty good at surveying. I bet they know the exact size of that place. But the maps are... I mean, I don't know how you go 69 miles north-south. It's big enough to do that, right?
Yeah, but that's not one experiment. They can just say that's the apparent flat Earth magic sky. That's what
no, but it's a measurement on the ground. This is the place where you are when you measure an angle.
The relation to Polaris, you said.
Yeah, but that's just a 1 degree change. You're just using that as a marker mathematically to say that there's a 90 and a 0. So you're sort of putting a distance there.
You think that they will change the math so that pi means 2 to fit the flat Earth? That's not realistic. What they do instead is say the sky is apparent. That's how they fit it. It's like you're not listening to them.
But the actual distances are on the maps. They are measured and they are able to be done. Like school kids could do this, then. Right? We could have a worldwide thing where schools can get involved. Anybody
That's your lesson.
Can measure an angle.
That's the lesson for you to know what Earth is.
Anyone can do it.
You don't listen to it.
Jin will tell you that measuring that angle means flat Earth, but I mean it doesn't. You're just measuring an angle and marking a position on the ground, and then measuring a distance between that one and another one. Right, that distance is a horizontal distance measured on a map. So flat earthers should really enjoy this sort of thing. Putting a ruler on a map will give you a horizontal distance, and that can be measured. Providing you measure the angle.
It might not be horizontal, though, depending on what words you want to use.
No, on the map, it's definitely horizontal.
Well, not on a globe.
When you put it on a flat map, it's horizontal.
Not on a globe map.
Distance measurement. Yeah, of course it is.
On a globe map, it's a curved measurement.
It's a straight, yeah.
No, the maps in reality, we're talking about local scale maps. That's a horizontal.
Some maps in reality are the shape of a globe, aren't they?
Well, yeah, but we're not going to use those. We're going to use the actual map that we're going to use, and we can put a point on here and a point on here, and then measure that.
Semantics means nothing then.
Yeah, this is like upside down. This is 1984 doublespeak.
What is?
Curved trajectory. Flat trajectory is a curve.
Non-Euclidian horizontal. That's Bev's contradiction.
Yeah, local is Euclidean, right?
So what does local mean? Like, so not globe, just like your reference point?
Well, you from point to point. You're going to use a map, and you're going to locate the point that you are on the map, because that's the thing about maps, right? Every map will have a place where it relates to reality. And that's what you're doing. You're putting 2 marks on a map that relate to reality, and then you're measuring the distance between them. And that's a horizontal distance on a map.
Yeah, it's on a map.
Earthers can do this. Anybody can do this.
Anyone can do. What does that even mean?
Well, you can measure an angle to Polaris. You can mark your place on a map. You can then go north or south, 69 point whatever miles, and measure another angle, right?
How do
and
you
then
know
mark
that the
that place on the map.
Is the Earth curved?
What?
You said it's a flat map. I just want to know, like, how do you know that the sky's curving or the Earth is curving?
It'll be because you end up with pi equaling 2, like I said.
That's where your point actually works. Right.
When you put all of these numbers together mathematically, you will end up with pi equaling 2 if you make the equator a circle.
Is this on the AE map in particular? When you made that declaration?
Anyone.
Oh, like we're trying to work out what the nature of the Earth is, and so I mean, it's kind of like once one suggests that it's not the globe, right? The interpretation is up to. I mean, you've got a multitude of options there. Just to funnel someone into the AE map is an erroneous proposition. So, like, who are you actually arguing with then? Like, if you want to argue with an AE person, I'd agree with you. I don't actually know, but. What would it be? I could actually put the Earth as an AE map, but the sky is doing something very sort of hyperbolic. And the way that the nature of the light arrives at our position is actually curving through space.
Yeah, well, I'd be willing to argue whether knowing that pi equals 2 is an actual knowing, because can it be known?
Can it be known that pi... Well, I mean, what would that interpretation be? If you suppose or impose the notion of the AE map, then yeah, pi, as far as the sky is concerned, in a hyperbolic geometry, which you can do, you can hyperbolically move light through space-time, right? It curves. We know refraction occurs. There may be other forms of, like, you know, bending and twisting of light that's occurring in the upper atmosphere. That's just not, like, me as a person. I cannot go up and perceive what's going on up there. So I'm bounded to the ground. So
yeah, that's why the pi equaling 2 is just two lines perpendicular to each other with that ratio, right? If you make one of them a circle, then that's how these two lines are, but it's a ratio. Pi is a ratio, so the ratio is between these two straight. They are straight lines, but in order for you to say pi, you're saying one of them is actually a circumference, because that's the understanding of what pi is. So this is, right, an argument that Eggshell sort of brought in, but it's an argument to the people who consider the equator as a circle in particular. It was particularly made for the flat Earth debate.
Circle in the sky or a circle on the
Earth? But wait a minute, because they have a circle of equal altitude of 0, particularly 10th man. Now he gave them that circle, and that's what this particular mathematical argument goes to show, that it can't be that, because you end up with pi equaling 2.
But the circle is the same on flat Earth and globe. It's when you go past outside the equator.
No, not for these measurements, Dawn. This is particularly just to the equator, from the 90.
So why would the flat Earth equator be different to the globe one? What's the reasoning?
You'll have to ask the flat earthers. They're not really bothered about.
If you can't tell me, I'm going to put that in the bin.
It's not different. They say it's 24,901.
It's not different. So it's the same. You agree with me?
So then actual numbers for the 6,210.
So how is it debunked? If you agree with me, it's the same.
Agree with you what?
The equator's the same on flat Earth as globe Earth.
You'll have to have a word with the flat earthers about that, Dawn.
Oh, okay.
They get a bit touchy.
Why would it be different?
Because the radius of the flat Earth is 6,210. Dawn.
What? How different is it?
It makes pi equaling 2, Dawn.
No, that's when you
Welcome
do distance
to the
measurements
argument,
from
Dawn.
the equator.
Actually, that's a good point. You have to go beyond the equator to make the pi equal 2.
What, the flat Earth equator at 0 degrees?
Is the pi equaling 2 occurring inside of the above? What would you say? In the northern aspect?
Yes.
Of the equator, or the southern aspect of the equator?
Just in the north, because this is Polaris.
It's both,
privilege.
but it's not at the equator.
No,
the equator's the same.
I would have thought that pi equaling 2 only, like from what I saw of Eggshell's presentation, is an aspect of the southern hemisphere, not of the northern.
No, he was talking like all southerners talk about the northern, right? But because you're in the south, you think of it as though that, but they're not. They're just talking in the north relative to Polaris, and the 0 equator that's the equator where you can't see.
I brought up the idea of pi equaling 2 because when Eggshells was presenting it, he was talking about the distance, or what is it? The distance of the continental Australia.
Mm-hmm.
That's when he brought it up. So he didn't bring it up when it came to the northern hemisphere. He sort of just
completely mixed up, right?
He only brought it up about the southern hemisphere. I don't know. I'd have to ask him whether or not his interpretation is applying to the northern hemisphere as well.
Well, the measured flat destructive dichotomy is just talking about Polaris in the north to the equator. That's the distance.
Okay, because that's a center point. Whereas when the globe does its like declinations and measurements, it's got the sort of a fictional observer at the center of Earth, because the sky, remember, as I said before, is flat. It's perceived as flat. That's why they get away with this geometry. You recognize that their articulation or interpretation of the sky requires the observer to be at the center of the Earth, not necessarily on the surface?
I understand completely that people have a different view of non-Euclidean because everybody thinks Euclidean. So non-Euclidean is difficult.
I'd like you to unpack that.
For most people.
I mean, okay, I got into a bit of a conversation the other day about non-Euclidean. Would you say that when light starts to refract, is that non-Euclidean at that point, or is it still Euclidean?
Well, I would say non-Euclidean is anything that doesn't go with the reasoning process of Euclidean, like a logic. Really?
Okay, so the black swan is a Euclidean a Euclidean conclusion.
Yeah.
Well, perspective first and foremost breaks the concept of Euclidean.
But yeah, right? But like this is where the argument seems to get a bit funny. It's like it's Euclidean within the perspective. It's kind of
excuse me, orthographic. Yeah. Orthographic. So like when you look from a side view, you're looking at like pure geometry. But then perspective creates this dimensional shift. But yeah, Euclidean, how does that exactly interact with this idea?
Euclid did a book, one called The Elements of Geometry, and there's another one where he did optics. So they're totally separate ideas. And for you to bring perspective in, you're combining two different aspects. So what we're talking about here is
the way we perceive the world is actually a combination of the two, right?
The Euclidean reasoning process, right? That goes through both of them. It's a logical form. And for it to be not that means it's
okay. The horizon doesn't present itself as Euclidean. That's what I want to suggest here, right? So it does, like, do we include refraction within the orthodoxy of the Euclidean interpretation? So do you perceive the world in Euclidean, but then when it gets to the horizon, right, things begin to bend and melt, like they warp and shape.
Well, no, the plane of the horizon is horizontal, so that's I would say that's totally Euclidean.
Okay, but like acknowledging that we can sometimes see a little bit further, and then that distance retracts, so the horizon contracts and expands regularly, right? So it's
you can see further than what
of refraction. The geometric curve.
What geometric curve? The plane of the horizon.
Well, the globe's geometric curve. You can see further than the geometric curve. That's the whole idea of the black swan. That's what you were saying. Like, it's a false argument before.
Are you thinking it's a sphere?
No, I'm talking about your Euclidean perception in the world.
Non-Euclidean. Are you talking about the Euclidean local?
Do we perceive? Is it local or is it a horizon? What are you referring to?
The plane of the horizon. That's what I consider the plane of the horizon. Or are you talking about the topographic horizon?
No, I'm talking about the fact that the horizon shifts and warps. On one day, you can see a little bit further than the next day. Even throughout the course of the day, that distance changes. That's like, in my interpretation of Euclidean, that is the bending and warping of the light. So it's no longer taking on a Euclidean geometry. Some people have argued against that, saying that, well, when you add the refraction in, it's still Euclidean because you've got to interpret the refraction and what's going on.
Yeah, I don't know. I think you guys seem to have a different idea of what Euclidean is. I mean, you seem to include refraction for some reason, and I mean that's got nothing to do with the geometric understanding.
Because when you perceive the horizon, you can see beyond the geometric curve.
You're getting
I can tell a triangle's a triangle. What's going on here? I know a triangle. Like I see a triangle. I see a triangle.
Okay, a straight line.
Morphology in its form.
A straight line.
I mean, it's not a pure straight line, but I mean, like, if you carve a triangle into a piece of wood, for all intents and purposes, like symbolically, we conclude that's a triangle.
Okay, so a straight line then. Do you understand what a straight line is?
So when you look at something, do you think that when you look at that fish through the water, that you're perceiving Euclidean geometry? Because we know that if you shoot that spear where the fish appears to be, you're going to miss the fish.
That straight line that you're imagining, that you're shooting, is that a Euclidean understanding?
From my interpretation, yeah.
Okay. Can you imagine a non-Euclidean straight line?
Yeah, because the light bends and actually the fish is not where it's at. So you don't perceive where the fish is at. You don't perceive the world in Euclidean geometry. It's only when you're within the necessary, like, refractive medium. If you're in the same refractive medium in your perception as the other thing is, presuming you're not like going through a body of water or a surface of water, the object is like, that's why you can, ballistically speaking, like, you can shoot an arrow, presuming the arrow goes directly straight, you're going to hit the target. But if you say you're in a refractive index and there's a differential between the observer and the the destination, or the thing you're trying to shoot, then you've got to account for that refraction. So is that Euclidean at that point, or is it not?
Yeah, I'm still at the straight line, mate.
It's not a straight line though, because you're gonna miss the target.
Your non-Euclidean straight line, right?
You're going to miss the target in your perception. You do not perceive the world. You don't perceive the world in a Euclidean geometry. Then you do not perceive the world in a Euclidean geometry. Sorry, you're done there.
The same as your Euclidean straight line?
No, it's not. It's been refracted.
Okay, so what you've actually done there is you've imagined a not Euclidean straight line. And what I said,
that's the way I perceive the world.
Yeah, that's what I said. I said, can you imagine a non-Euclidean straight line?
Yes, I exist within a non-Euclidean geometry under that of what I think that you're trying to infer. Yeah, I perceive the world in a non-Euclidean geometry because of the nature of light bending and warping.
Right. Now, within your
this is not a difficult concept, man.
Within your non-Euclidean geometry that you do imagine, can you imagine a square?
Yeah, I can imagine a square.
Right, a square is a Euclidean shape. Solely Euclidean. It doesn't exist in any other geometries. So you can't be imagining a non-Euclidean geometry because you can imagine a square, and a square is a Euclidean geometry.
Am I imagining it, or am I actually perceiving a square? What do you mean? What do you mean by this?
Well, I mean, you can
imagination, or is it perception? Which one?
Well, you can actually do geometry to show a Euclidean understanding, right? You can form
You can actually do it if you go up and measure the object, but as I said before, if you go measure where the fish is, you're not going to hit the fish because it's in a different refracted medium, so it's non-Euclidean at that point. The fish is not where it presents itself to be, just as the cube doesn't present itself where to be. And in fact, you could even say that the cube starts morphing. It'll change shape because you'll perceive it from a higher point. So if you're looking at a square, or a prism, I need to put it into 3-dimensional at that point, but you perceive the cube from a higher position. So therefore, you're looking at the top end. That's you. Well, this is the argument I got into the other day. Is like when you talk about Euclidean, are you including refraction? And you guys pointed out before, as far as modus tollens is concerned in the Black Swan, you said he's not including refraction.
That's Euclidean. Modus tollens, deductive logic, that's Euclidean.
No, Black Swan is a Euclidean geometry.
No, that's a fallacious
modus tollens is just an argumentation. Like you got to, if P is therefore Q and all the rest of it, right? It's you can apply anything to that. It's not just geometry.
That's Euclidean. Yes, that's the form that Euclidean geometry comes in. That logic.
Yeah, and it's false. Great. So you agree that you do not see in Euclidean geometry anymore.
You don't see in Euclidean geometry at all, because that's not what Euclidean geometry is. You don't. It's got nothing to do with your eyes or vision.
Oh yeah.
I think he said
geometry. Right.
I think he said the form of the argument was false, not that anything about it being Euclidean was false.
I don't know if that's a rebuttal to.
They think the Black Swans morphed into the modus tollens and all of that now. Because we went over that.
No,
I mean that's for
QE. I appreciate you coming to the. I appreciate Bev you coming and showing me that information. I never I wasn't in deep of this conversation in a broader context of modus tollens, what QE was sort of putting forward, and I reject it outright. So thank you for presenting. Now I understand why he became popular, why he messed up all the interpretations of flat Earth. Yeah, it's
maybe why flat earthers don't know how to form an argument, right? Because that is the most simple form of argument. And they've been messed up, so they don't even know how to make the most simple form of argument. And modus tollens.
You're just talking about a guy, and a guy is rather influential, and you're going to look at the nature of. Yeah, but why people
flat earthers and their inability to make arguments.
As soon as you talk about flat earthers, you're talking dude. As soon as you talk about flat earthers, you're talking about people.
Yeah,
people are not. They're not Euclidean. They're not a geometric argument.
No, let's clarify something. Arguing is something that women do.
Yeah, there you go.
Well,
that's basically what you're thinking of.
So maybe there's a good reason why flat earthers can't have good arguments because they reject their womanly behaviors.
Did I just hear you, Riksky, say you just understood something about the Black Swan you didn't understand before? Is that what I heard you say?
Yeah, because people just talked about it, sort of they already know the argument, and they sort of, there's nuances to that statement as far as the context and social incursion that occurred there. So yeah, I mean, it just sort of gave me a bit of a sort of, and what would you call it, more perspective on why that became such a big thing. Why people keep saying it all the time.
Was it an understanding about the logical form being false, or something else?
Yes, definitely. It's a bad argument.
Okay, so previous to that, you thought it was a good argument.
No, I was never a proponent of it. I sort of looked at it and I was like, oh, it's kind of interesting, but I've never sort of looked at the idea that
in the terms of the logical form, you didn't notice that yourself.
I never paid attention to it. There's many different things in this topic of discussion, and that particular one was just not really of interest to me. So, but I like people bringing up other things that I'm not aware of, and giving a new spin on it, so that I can understand for sure.
Yeah, for those flat earthers who equally miss it or misunderstand it, then that's the flat earthers that's been spoken about. Which would have included you before you understood it. Okay, so you're talking about people seem to be arguing about that, but you were one of those people until you realized
I never used the argument. If I didn't understand the argument, then I wouldn't have used it.
Yeah, but you weren't aware of the fallacious form, logical form of it, though.
Yeah, true. In its formalities, yeah, for sure.
So when Bev said the flat earthers, that would have included you at some point.
No, because I never used that. The idea of like grouping a whole bunch of people into a certain sort of inclination, a way of thinking is that's an erroneous proposition. If it put that statement into a modus ponens for me, all flat earthers must think this because of this. Like how you go about it, construct it for me.
No, but it's talking about a general understanding of how you would form a modus tollens. For people who didn't notice, they may think that was the way to do it because they see it and they think, oh, that's the way to do it, and it's like it can become a subconscious, idea, subconscious approach to it in the future for them. Because there's a lot of people stand by it strongly.
Just as same way that when you go to primary school and you're showing a bunch of balls spinning around other balls, that upon reflection now, you've got to recognize as a false proposition.
Yeah, that's not exclusive to balls, though, is it? And the ball world, that also happens in the flat world
saying,
too.
The same problem. When you point out that, what is it? The flat earthers were led down a garden path. Do you understand the complex psychologically of the garden path? Thinking that you're experiencing nature, but it's actually been curated for you, domesticated by human beings. That's what you think of nature at that point. Because of the garden, because gardens they're not a forest, right? A forest is natural, whereas man touches a garden, right? We manipulate a garden, so that's the garden path at that point, and that's what you're being led down. And it's an erroneous proposition.
In this case, it's a flat earther leading the other flat earthers down the garden path, so isn't it?
You got to presume that person's an authentic presentation of the interpretation. Then.
Well, I know it's been lots of people's appeal to authority.
Now, if the majority of flat earthers reject authority, why would you think that they're now following someone else? That don't make any sense.
Brilliant.
And by using.
Because most flat earthers are anti-establishment, right? They're anti-government, but now then what? You're claiming that they have like a savior or something that they're listening to? Some numpty? Some crown muncher?
If they stand by the QE's Black Swan,
who follows crown munchers,
this was the Globe Destroyer.
Indeed is the case.
This is where he got his name. QE made this argument and totally.
No, but you're appealing to another authority figure. You're just appealing to another authority figure. You're falling into the same premise as like the problem with the globe.
For years.
No, dude, you said before that you're most interested about the way that people move and shake. I'm really I'm fascinated by that. You've come to that conclusion, and that you think that one person with a bad argument is the reason for the flat Earth. Like that's a really wrong proposition. I'd like you to put that into a modus ponens for me.
Where'd you get that from?
That's a pretty broad and general claim, that is.
Modus ponens.
Because QE says that what is it? Black Swan is correct. All flat earthers must think the same thing. Is that your proposition?
As well. It was the number one argument.
Is that the correct modus ponens that you guys are basically instantiating then? Because
no, it's just for those that do.
Because one flat earther said something, all the flat earthers must believe it. Incorrect.
Wait,
proposition.
didn't say
so it
all.
would be hold on. So it would be if QE then QE.
No, just for those who say if QE then QE. Yeah, for those. If it isn't you, then don't worry about it. But there are a lot who stand by it.
Yeah. People are misled by ideas. Actually, the globe is the greatest presentation.
Yeah.
People can be misled.
Yeah.
Yes, granted.
Yeah.
Yeah, I mean, people stand by Donald Trump all day long, right? Bunch of idiots.
Yeah, but flat earthers aren't devoid of that situation, are they? You know,
no, we're still human. It's a human problem.
Leading people astray.
Well, I mean, it depends whether they're controlled opposition or not, but that's another conversation.
Well, it just might be they might be dumb and they heard somebody they thought was good, and they carried on repeating it.
They could be sort of enthusiastic about an idea, and in the nature of spectacle, which is that of like what garners human attention, this person garners human attention because of the nature of the way they conduct themselves. And you got to look at then what makes the pop star, what makes someone influential. And it's this sort of, it's the spectacle. This guy is a sort of, they appreciated perhaps his charisma, if he has that, but his ignorance or his, and they forego the notion that he might be incorrect because they see him fighting for the same ideas, which is what I think leads people astray constantly. Just because you're a Christian, someone says a Christian argument and they're garnering a lot of attention, you think that the idea is right. Not because the idea is actually right, but because they've garnered attention. We've got a misconveyance of value of information or idea, given the fact that they have a social value, right? There's been misconstrued with the true value of argumentation. That's why fallacies exist.
But that's what we were doing this morning, right? And we've gone from the argument to the angle. And then we're now in measured flat territory, right? This is years ago, that argument. But now we're in measured flat, which is what the argument we were trying to talk to Jin about earlier, right? Made by Elderbear. The measured flat destructive dichotomy is an argument that was made by Elderbear. Now, flat earthers suddenly don't want to talk about arguments and stuff. They want to say it's for women. Things like that, right? But these are...
I've always said stuff like that. See, there's nothing to debate. I realize that, and people arguing about stuff they're just behaving like women because that's what women do. They argue about how they feel about things, which is what people are doing.
Yeah, you're talking about
the argument at that point, I think, would be that people...
But that's not what we're talking about here. We're talking about an actual argument that's been formed.
Do people argue about things they're not necessarily comfortable with, or they don't instantiate absolute knowledge, which is why I find it's funny, right, that you got globers who think it's a globe. They it must assertively be a globe, and therefore, but they still coming around.
The best argument that you flat earthers have
get out of the conversation
is a fallacious one that QE made.
Now, tell me hold on. What exactly is an argument? Just give me one, not related to the shape of the Earth.
That's a good question.
The black swan that we just posted.
No, not related to the shape of the Earth.
I'm sorry. Argument.
I'm sorry. Give me an argument. Give me an argument about women's fashion.
I haven't got a clue about anything.
Yeah, so I want you to give me an argument that has nothing to do with the shape of the Earth. Give me an argument that has nothing to do with what you usually argue about. I want a real argument.
The argument. Do you want that?
Not the argument, dude. That's
a
geometric argument, and geometry is like...
I called it the argument, right? Because... that's what it is. It's an argument, and I decided to make it because it was a modus ponens, a positive argument.
Can you articulate it for us?
I'll put it in the chat for you, so you can actually see it.
Is it a geometric argument?
It's an argument. You can call it, if you want to call it geometric, you're going to be talking about a Euclidean form.
For something that's not related to the shape of the Earth. If you can't form an argument that's not related to the shape of the Earth, I don't know why you call yourself an expert in argumentation. Give me something, dude.
Right.
Like if a male excretes their semen into a female, there's a 50% chance of them having, of conception. Like, give me an argument. I don't know what it is. Like something else in nature.
Inductive argument. I wouldn't bother doing that. I like to stick to deductive form.
Deductive. Well, okay, so give us one.
So you only operate in deductive argumentation. Okay.
That?
Is that like a rule of thumb as far as argumentation is concerned? It must be sort of deductively orientated. It can't be inductive or abductively orientated.
These ones are based on FP then Q, most simplest form. That was the idea, to make
an argument
as simple as possible. It's a modus ponens.
No, but you stated that it was you prefer deductive argumentation.
Yes.
This is the thing you're presenting. So
yes.
Does argumentation work in the inductive and abductive reasoning aspects, or only in deductive?
Yeah, of course there's inductive reasoning, yeah.
Okay.
But deductive is far more definitive for an argument form.
Gotcha. Okay. So why does it establish itself more? Like, why does deductive rationale suit argumentation more than inductive or abductive?
I made that one to explain what the black swan is, right? So the black swan, for that particular argument, would you be showing a horizontal that was either not parallel with another horizontal or not parallel with the plane of the horizon? That would be what the black swan is for that argument.
You can't get away from it. Can you provide another deductive modus ponens that is not geometrically based, or is it
modus ponens? I can put a modus ponens up there for you to critique.
I don't think you're actually answering my question. You're just saying something about modus ponens.
Well, there's only one person that we know about the modus ponens, right?
I'm actually not familiar with that person who created that proposition. Although I would argue that, like, just because you attribute it to one person doesn't mean it's necessarily like where it came from and that it didn't exist before that person interpreted it.
Well, I bet you can't name the modus ponens argument that you're thinking of, or the form.
You think I can't name the thing that I'm?
I bet you can't. Yeah, I bet you can't give us the form for modus ponens. Modus ponens is FP. Thank you.
Q. If not,
breaking up. Was that him or me?
That's him.
Convenient. Always does that. I think Discord saves people.
Well, I'm still waiting for an argument that has nothing to do with flat Earth.
You're breaking up.
No, it's you that's breaking up, Rick.
That's got nothing to do with flat Earth.
What? No. I want to. So an argument, you should be able to vocalize. So I want you to vocalize an argument that has nothing to do with flat Earth.
That hasn't got anything to do with flat Earth. That's just an argument that you can make in reality, right? It's got fuck all to do with flat Earth.
I haven't heard it. When did you say it?
It's in the chat, in the.
Oh no, I want you to vocalize it because the argument can be vocalized.
If all horizontal planes are parallel to the plane of the horizon, P, then all horizontal planes will be parallel to one another, Q. By definition, all horizontals are parallel to the plane of the horizon. P is true. If P is true, then Q is true. Q is true, therefore all horizontal planes will be parallel to one another. Say it with confidence.
How are you measuring parallel? How are you measuring parallel?
Yeah, but hold on, but the thing is that really an argument?
Yeah, it's the modus ponens.
Yeah, but I don't understand how it's an argument. What are you arguing for?
It's the form of the argument, the modus ponens. That's how it works.
Yeah, but what are you arguing for?
All horizontals being parallel.
Okay, and what? And they're not?
Yeah, they are. That's the conclusion of the argument.
So is it an argument then if you're just stating the conclusion?
Yeah, it's the modus ponens.
That don't make any sense.
Doesn't that mean it's flat, dude?
What, the argument?
Aren't you basically insenting at that point it must be flat?
Well, no. I mean, that's, you've just tagged that on. That's not what it states. It says all horizontal planes are parallel to one another.
That means, yeah. So if they're all horizontal and they're all parallel, then that's what like, you know, all of those horizontals are parallel to one another. So as you can extend those lines through, then they're all flat with one another. That's it. We're done.
Can you argue for that then, Riksky? You make an argument for that?
Based on what interpretation of the measurement? Like what is being used to measure?
You make an argument about the all horizontals being parallel to the plane of the horizon.
Yeah, just use that as a lemma, right?
Having anything to do with flat. You need to relate that to flat now. Because the argument doesn't relate that to anything that says flat in it. You'll need to do that if you claim that's what it is. You make an argument. That's for you to do.
The all horizontals
mathematics
are like, what would you call, like all horizontals are parallel with one another, i.e. flat.
Well, is that you? You've tagged an IE on the end of it, right?
That's it.
That's fine. I mean, it's just another terminology for it. But so all horizontals are parallel. Done. Yep. Okay. Thank you. We're done.
Yeah, it's just claims about mathematics, flat, is it? Nothing to do with flat, though, is it?
I'm not worried about flat. You told me to take flat out. I don't need flat in there, so you told me to take it out, and I proposed the argument.
You make an argument. You make an argument including flat. I didn't say take it out. You added it, so you need to make an argument for that.
What is, like, dude? What is your interpretation of flat at that point? You guys do some.
My TV is flat. It's not horizontal though.
Don't know what that's got to do with the shape of the Earth, man.
Well, that wouldn't make horizontal being flat, would it? If it's vertical.
Still don't know what that's got to do with the shape of the Earth.
You brought the shape of the Earth to it. Flat bit. It's not in the argument.
Multiple horizontal measurements. What is it? Multiple in
There's no measurements.
You just keep it within the argument, right? That's because that's the key to this.
Just refine math. That's all it does.
Within the argument. It's got nothing to do with the shape of the Earth, right?
Multiple horizontals that are parallel. Go. I mean, definitionally speaking, what would you call that? You know, like the term reality, flat. Right? You want me to include the term flat, but you seem to want to say that when I insert flat, you don't like that incursion. So
no, that is reality, and we know reality is not flat, right?
No, we don't know that.
What do you mean?
How do you know that by definition, in reality, all horizontals are parallel?
That's just in that argument, right?
The sky presents itself as flat.
Well, it's just the argument just verifies math.
How does the sky represent itself as flat? What's the argument for that?
Either the Earth is going to be curving or the sky is curving.
I don't imagine clouds.
They're necessary. What would the terminology be?
You need an argument. What about an argument, Riksky? Make an argument for it about flat skies.
If the ground is flat, the sky must be curving. Done.
How does that relate? What do you mean? Why must it? Why must it? Must.
Well, because the alternative, like the globe interpretation at the moment, is essentially that the sky is not curving, the sky is flat, and therefore the ground must be curving.
Wow.
That's the only connection there at all.
Yeah, because you can just invert.
You know what that sounds like to me, Riksky? That sounds like some non-Euclidean reasoning, right? It's just nonsense.
Non-Euclidean reasoning, dude. You've got refraction, and you still haven't answered the problem of refraction within like Euclidean geometry.
Definitely non-Euclidean.
What are you talking about?
Well, it wasn't
a long way from this argument.
It wasn't like an argument like anybody else.
You still haven't actually resolved the issue of like whether the sky is flat or the Earth is flat. So, I mean, you do not seem to be willing to accept that the sky is flat.
We know the Earth's not flat.
The sky is perceived as flat. You've got a little bit of parallax going on, right?
I don't perceive it as flat.
I don't know.
Einsteinian relativity, like perception, right? Within that that proposition of perception, then the sky is flat. That's what the whole documentary of the principle was about. I've already brought this up to you.
Well, we know the Earth's not flat. So what does that make the Earth?
No, we don't know that. That's a bad argument. You do not know that. You can't make that in an argumentation.
It's just a statement.
Just an observation.
It's also a weird statement saying we know. Speak for yourself.
Well, I know it's not flat as well.
Well,
right?
if
mountains aren't flat.
Although it's self-evident.
Okay, look, flat is not a geometrical sort of argument, dude. It's not the sky. Like flat is not a geometric argument, dude. It's just not. It's just that the horizontals are all parallel.
Why did you take it from geometry then? Why did you infer it from geometry, Riksky? Riksky, why did you infer it from the argument?
When I say flat, all horizontals are parallel. Just from now on in the conversation, redefine the term flat, right?
That is geometric. Parallel is a geometric definition.
Yeah, fine. I'm fine with that.
So it is geometric then, right? Or is this one of those angle, triangle, non-geometric triangles that you can consider as a triangle type situation?
You do not perceive the world in Euclidean geometry.
Like think about it geometrically, but it's not really geometric.
You perceive the world within you perceive the world within a refractive environment. Yeah.
You perceive the world as
non-Euclidean.
The horizontal is flat, don't you? That's for you. You perceive the world that horizontal is flat.
Thanks for the commentary.
Argumentation. If you see beyond the geometric horizon, you do not see in Euclidean geometry. Prove me wrong.
But isn't horizontal two-dimensional? So it has to be flat by definition.
I'm not sure about that, but I want those guys to answer my response.
Like I said, you can have flat in the orientation of vertical too. So that doesn't work, right? It's not horizontal though. It doesn't fit within the argument. Okay, can you see that?
But horizontal is two-dimensional.
Horizontal isn't vertical.
Horizontal is only an indication of direction. Horizontal, vertical, it doesn't have a dimension.
Oh, yeah, horizontal plane would be two-dimensional. Yeah, sure.
Yeah. And vertical.
So the plane of the horizon would only work on a exactly flat curve.
Is a piece of paper two-dimensional?
No, it's an object.
Yeah, so then how can you have anything be two-dimensional? Are you retarded?
If it's a plane, then it's two-dimensional. That's geometry.
That's true.
Yeah.
Where do you see two-dimensional things? Show me one.
In Webb's argument, he says that
nowhere,
there's a plane
so they don't exist.
So
stick to reality. Stick to reality.
Yeah, in reality, there are no planes. Yeah, planes don't exist in reality.
Well, they do. I see them flying all the time.
Yeah, what is a plane?
Not true.
Does it mean you've got to be the authority if you've got the server?
What do they mean by the plane of existence?
What you say goes.
The plane of existence must appear like what is that? It must be on a curve. The plane of existence must be on a curve. That statement actually must be relative to the globe. When we call the thing the plane of existence, right? You're familiar with that terminology, the plane of existence. It's not like I haven't pulled that rabbit out of a hat somewhere. There is a terminology called the plane of existence. We know what that means.
That you
must also
that it's
term called airplane.
So when you use the terminology plane of existence, you must think that you're on a globe. So you think that plane, when you use the term plane, is it flat?
I don't think globe when I think plane. I think Euclidean.
Exactly. But you call it the plane of existence. Well, one could call it the plane of existence.
I don't think of plane of existence as being geometric.
Many people perceive it in a sort of like the terminology of like a spiritual interpretation, but the plane of existence is a definitive terminology for talking about our reality, right? And my question to you then is, what do you think that they mean by plane of existence? Define that term plane within that statement, because that's a common terminology.
Wow, that's some ECV. That's proper deflection. Where did that come from? Is that the closest plane that you could think of?
It occurred. You guys were basically playing around with the definition of flat. And when I say flat, I made a statement, topological plane, right? And you didn't like that. You said that's not a flat. Okay, so now I'm asking you, what does the plane of existence mean then?
I haven't got a clue.
Yeah, exactly.
Someone who
sounds like some sort of philosophical term or something, some sort of psychological.
Or it could actually be reflective of reality, because that's a common terminology, the plane of existence. People say that.
Let's say
it's a common use of terminology.
To the individual to define it, but there wouldn't be words for it.
So then why is it in common use?
Why is airplane in common use, even though it's a solid object that isn't flat?
Because it's flying across the plane, so it's aeroplaning across the surface of the earth. It's not going around the curve.
It's not.
The plane of the horizon is just to show a geometric understanding of what your reality is.
But when you use language, you recognize that it's not necessarily determining like the way that you think about the world or in actual in geometric terms. It's more a kind of like a, what do you call it, like a philosophical or a kind of an interpretive way that one may say things. So if you call it a plane,
the plane of the horizon was meant exactly so you could associate it with horizontal. That was the purpose of making that argument. So you could relate horizontals to the plane of the horizon, like most people do.
So yeah, your perception of reality, which you claim is Euclidean, is flat. Thank you.
No,
you're saying that there's a plane of horizon, which means that the plane would be flat. That's 2D.
See, like now you're just imposing 2D upon the terminology of flat, and that's not what's being happening here. So
flat.
I mean, pardon?
So you keep mentioning flat, and it's not in the argument.
Yeah,
that's your thing.
As I said before, all horizontals are parallel. And I'm using that terminology.
Yeah, but that doesn't infer flat,
what flat is. No, but I'm using that terminology. In this discussion, furthermore, I'm using
the terminology. Use the argument to back that up.
I've already said that.
You can say that statement confidently because the argument's there to back you up. Right?
Thank you.
It's you.
And you like argumentation.
You got your motive from that. Now that's ridiculous, right? You've got to realize that horizontal.
No, what's ridiculous?
Is
an
orientation. Right? You can't
what do you mean saying that? What do you mean saying that it's an orientation, dude? What does that mean? Is that perception?
All horizontals are not parallel.
Everybody knows
and also,
about these verticals.
Not every. No, dude. Like the shearing, like the example that flat earthers exist. If you say that all horizontals are not that, I mean, you're denying a whole bunch of people's perceptions. So that's just not the way. Like if you went, no, it's not going to float, dude.
Yeah, and like the argument talks about horizontal planes. Planes are two-dimensional. They don't have any curves on them.
Are you talking about an aeroplane?
No. In Bev's argument, it talks about horizontal planes. Planes are two-dimensional.
If they're all
he's
parallel,
claiming that the Earth is flat.
Right? If you take an elevation point, right, upon the Earth, right, and project that out, and then if you take a what is that, like a point on the ocean and you project that out, they will be parallel. Prove me wrong.
How can you project a point? What do you mean?
Yeah, the ocean isn't horizontal though. Riksky,
if you move left or right,
horizontal.
Point, they will not be parallel.
I didn't say the ocean, did I? I said at the point of the ocean, if you project that plane out, I'm not measuring it according to the ocean. I'm measuring it according to the horizon. Yeah.
It's pretty easy to prove you're wrong.
Horizontal.
It's pretty easy to prove you're wrong.
How so?
It's because no verticals, no plumb lines are ever parallel. So therefore, no horizontals can be. And given that plumb lines are perpendicular to horizontals, they can never be.
How do you know that?
How do I know what?
It's one of the
how do you know that plumb lines are not parallel?
The Earth is a globe. That's how I know that.
No, that's an assertion. That's a bad modus ponens. Okay.
The Earth's a globe.
Prove it.
That's just an assertion, a belief. That's fine. But can you show me parallels? Can you show me that those plumb lines are parallel? Or can you show me them converging?
Plumb lines cannot be parallel.
Show me diverging.
Can you show me that?
Show it.
I think it's easy to make the argument same way that Bev does. If the Earth is spherical, then plumb lines are not parallel. By definition, the Earth is spherical. Therefore, plumb lines are not parallel.
Show me the plumb lines, dude.
Exactly.
Just argument from definition, just like Bev had.
Dude, if you're relying on the plumb lines and you're just assuming they're converging into the center of the Earth, I can understand your reasoning, but you actually can't show me that the plumb lines are converging.
Of course you can.
Show me what measurements. Show me the measurements.
All right,
anything.
Pick a bridge.
No, that's to the sky. You're using the sky now. You're like
we're talking about. It's not using the sky.
No, you're using plumb lines, and now you're jumping to the sky and using a zenith point.
No one said sky.
Lines? You said plumb. I want you to show me using plumb, not zenith lines.
Reciprocal zenith angles are measured with theodolites pointing at each other, not the sky.
That is the sky.
It's not the sky.
I want you to show me. No, that's plumb lines. You've jumped from plumb lines to zenith angles.
Let's get it.
Well, you go through the sky to make your angle observations. Different elevation, your bigger triangles at different elevation, or your left to right. I mean, dude, you know that you're looking through optics whenever they come back with these results. You guys never present these results ever. Present them to the level of where Jeremy can swat your ass down. You ain't got shit.
I want converging plumb lines, dude. I want converging plumb lines, and you show me that. Don't jump.
Good.
Don't jump.
If you just be quiet for a minute, I'll explain it to you.
No,
if you just be quiet for a minute, I'll tell you how. All right. Pick a long bridge. Whenever they build a bridge, they build they build the pylons plumb. But how come the tops of the pylons are further apart than the bottoms?
Okay.
If they make every pylon plumb, how come the tops are further apart than the bottoms?
Because that's engineering, and if you want to deal with a weight in the center, you bend the two sort of pylons away from one another.
No,
that's an engineering. That's an engineering solution.
You're not an engineer. I am.
Dude, I'm an architect.
Every pylon has to be plumb.
Yeah, but you've already
you said that they're not plumb. You said that they're moving away from one another.
No, you threw the argument out, Riksky. You screwed yourself.
Every pylon has to be plumb. But at the tops of every pylon the tops of pylons are further apart than the bottoms of the pylons, even though each pylon is plumb.
I doubt that you actually have a measurement of that. I'd like to see one. If you've got one, go ahead.
I guarantee it. I guarantee it.
Well, you've got to show me both that the distance at the higher point is further apart than the lower point, and then you also need to show me
100%. I'll put $1 million on it.
Yeah, you can show me that part, but then you also need to show me that those pylons are actually plumb.
Absolutely.
That's the critical. They're not plumb, bro.
Absolutely, they are.
Granted, they're not.
Show him the geometry.
I can demonstrate this using a spaghetti bridge, right? I could use a spaghetti bridge and show you a diverging beam point, right, or a column point. I can show you diverging columns, and I can show you, right, just within a spaghetti bridge.
Try and make an argument without geometry.
Do you mind to go?
You're changing stop changing the aspect of the discussion. We're talking about like diverging plumb lines and a correlation with bridges.
No, we weren't.
Yeah,
you were talking about the argument.
Yeah, don't talk
about the argument. You switched. You lost. Hang on, Riksky. We were talking about the argument.
Hey, we're going to need some order in this room. You guys are going crazy.
One at a time.
Come on. One at a time. Can we just get like one person to focus? And Bev, please don't cut in every single time somebody says something.
There's only two people at the most talking to Riksky initially.
I make a reasonable argument, and then all of a sudden it gets shifted to another topic. So we went from plumb lines converging or being parallel to all of a sudden zenith lines to all of a sudden bridges and the way they're constructed, right? So we just jumped through like 3 or 4 different pocket holes, and we haven't got actually a sentiment of what's going on at large, because the conversation keeps moving as soon as I seem to present something that is, I don't know, reasonable.
Bridges are the evidence that the plumb lines are not parallel.
I disagree. You got to show me that those columns for the bridges are actually, what would you call it? They're plumb.
If I show you that, will you stop being a flat earther?
Good question.
If I show that to you, will you stop being a flat earther?
I would need to antagonize the integrity of the information. So yeah, I can't confirm that necessarily. No.
I can give you lots more than that, by the way. Do you know that the distance along the equator between two longitudes
now we jump
is
off to
greater?
a different proposition.
No,
this is
no,
a different
I'm just
proposition
giving you
all of a
another
sudden.
one. I'm giving you another one.
Yeah, you just give me another one. You're not actually showing me evidence for the one that you instantiated that I need to calm the globe out. I want you to show me the information.
You're an intelligent person. You can think of 2 things at once. I'll show you the distance along the equator between longitudes.
You can't present your previous argument at the same time as you're presenting this argument. So you can't do 2 things at once, dude.
So that you can assimilate 2 things at once. You're not unintelligent. You can listen to 2 things to 2 different ideas at once.
Is this a demonstration of dogpiling?
Holy shit! Stop talking down to people and being condescending as if you knew more to them when they're asking you for evidence for something, and then you just talk down to them again. It's weird.
I thought 2 people were just having a discussion there.
Fine. No, 2 people.
As per the rules that were previously given.
He changed the argument. I asked him to resolve the first argument. He's going on to a next argument. And now you're saying that, well, that's all right. Get out of here.
It's just between you 2. Nobody else was dogfighting or anything.
So farther apart than in the northern hemisphere. Did y'all know that? The equator's irrelevant. But this guy wants to talk about the irrelevant part of it.
Of course, I mean, people navigate around the world every day. They use longitude and latitude coordinates, don't they?
But they don't verify if one's farther than the other. You're a fucking clown.
Of course they do. The distance between the distance along the equator.
Prove it. Bullshit. Prove it.
Especially if they
talking nonsense. That is the nature of human beings. We do diverge from the normative position. If you're claiming the normative position and not respecting the fact that people diverge from it, then you're actually not being very humanistic.
It's a human
That's a social argument, okay? That's it's not a geometric argument, right? And because you don't understand or appreciate the nature of human beings diverging from a common consensus, then you're just lacking fundamental. I don't know. You're like introspection of how human beings work.
It's one thing to have a hypothesis, to think up some hypothesis, and it's another thing to assert them as fact, like you do.
And it's another thing to
I'm not asserting anything as fact, dude. You're the one
We're
that's
not guaranteeing results. Exactly. You're guaranteeing your results, bro. There's nothing wrong with having an open mind or going, you know what? I might not know how to figure out this reason why this other thing that people think can only happen on a ball must be on a ball. It's okay to be like, I might not know. I want to go verify in some other ways. You can start by verifying in your way.
I'm here to help you. I'm here to help you do that.
Presuming that you can help us is another problem, man.
Yeah, bro. People might want to keep their mind open.
I'll show you that. I'll show you that the parallels are.
Dude, other people try to help me to be more Christian. Okay, they keep trying to tell me I need to be more Christian. Okay, are you also on their complex as well?
It's like
exactly.
So
all you're doing now is just basically propagating your own proposition in the world. You're just interested in conveying your idea and infecting your idea and your ultimate interpretation to other people. That's a human complex. You don't even understand that human complex at that point, then I don't know. Sociologically speaking, you haven't got an argument here. You don't understand how people think.
It's time you just face reality. The Earth is a globe.
The irony is that I grew up and I recognized that the globe could be a lie. Yeah, that's what I recognized. In my maturation process, I recognized that society is lying to us at large. Thank you.
Rubbish.
I appreciate that. I grew the fuck up.
Show your evidence.
Oh, that's different.
Is this like a gentleman's
I
club
am asserting that the Earth is a globe as a fact.
This is a fellow
There's nothing to do with what was being discussed.
Able to join in with it too. Like, how could we easily get you southern guys involved in measuring latitude so we can measure a difference between a 1 degree change in latitude?
Are you going to use the sky?
Use one of the stars. As a reference,
just
the way you used Polaris.
You're presuming the
Polaris
sky is flat.
doesn't move though. Phil.
You're presuming the sky is flat. You're presuming the sky is flat.
Riksky, he was talking to Phil. What are you butting in for?
I mean, it's a pretty open dialogue.
Let him answer about how it's